Okay, here we are. Esther, you probably need these, don't you? Okay, here we go. So today we want to continue our venture in taking antiderivatives, particularly in using the substitution rule. So just please note how we used to do this type of problem. We would have to take this thing to the third power and then distribute the 7x through. Anybody want to do that? And as soon as you say you do want to do that, then just realize I can make a new problem. I could say integral of 7x, 4x squared minus 3, and we could take it to the 1,000th power. So that looks absolutely absurd, doesn't it? And yet we're going to find out an easy way of going about that process, and I'm going to help you out. So all we do is we use substitution. And instead of using x, we're going to use a different variable. We're going to use u. And we choose u to be something that is kind of like the inside. Most of the time, it's whatever you would use for the inside if you're going to take the derivative and use a chain rule. Any thoughts on what u is going to be here? 4x squared minus 3. Excellent. Now what I do is I take the derivative of both sides. The derivative of u, we say, is du. Anybody the derivative of 4x squared minus 3? 8x dx. If you notice, we have a dx here, we have a dx here. We have an x here, we have an x here. But here we have an 8, and here we have a 7. Doesn't match up, does it? So therefore, I'm going to get rid of the 8, and I'm going to put a 7 in its place. Very simply. I'm just going to divide both sides by 8. So therefore, 1/8 du is equal to x dx. Because I have an 8 here, but what I want is a 7. Because the derivative of 4x squared is 8x. What can I now do to create a 7 there? Multiply by 7. So I get 7/8 du is equal to 7x dx. Let's now see what I have for a substitution. I have the integral, and instead of a 7x dx, what can I put in place of 7x dx? 7/8 du. I like to put the du there. I like to put the 7/8 out front when I have a multiplier. There's always going to be something that remains. So like in this case, what goes in for 4x squared minus 3? U. And the thing that we still have that doesn't go away is this cube, right? So that didn't go away. So I have u cubed. Now the problem is simple. What's the antiderivative of u cubed? U to the 4th over 4. And I'll simply take the u to the 4th over 4 and multiply it by 7/8. So we now have 7 times, what is u? 4x squared minus 3 to the 4th power over what? 32 plus a constant. I would like you to flip in your notes to the very back side where you have this space right here. Okay? We have the space right here. Okay, let's see where you get. Okay? Super important that we understand these two problems and that you ask questions as we go through. What was u? 4x squared minus 1. What is du? 8x dx. I don't want 8x dx. I want 2x dx. So I'll divide through by, sure, that's one way to do it. In order to get this to be a 2, I can divide by 4. So 1/4 du is equal to 2x dx. See that? So my substitution is good to go. I have integral 1/4 du. And when I do that, I like to cross off the 2x and the dx. This gets replaced by, and the thing that didn't go away was this, right? So it's u to the 10th. Antiderivative of u to the 10th, u to the 11th over 11. So I therefore have 4x squared minus 1 to the 11th power over 44 plus a constant. Turns out if we take that derivative, we would come up with that. There any questions on that first one? Then let's look at the second one. What is u here? 3x. So du is 3 dx. I don't have a 3 dx, I have a 2 dx. So I'll divide by 3, and I'll multiply by 2. So I can now get rid of 2 and dx with using what? 2/3 du. Yep, so this is going to be u, so I have sine of u. So remember, just like here, the 10 didn't go away, did it? And here, sine doesn't go away. We just need something we could take the antiderivative of. What's the antiderivative of sine? So we have negative 2/3 cosine of whatever u is. And what was u? 3x plus a constant. That's my antiderivative. Any questions on that one? I see some self-celebration. Good? Yes, sir.
So I have the negative 2 cosine of 3x all over.
Yep. That'd be fine. Yes. Okay, flip back to your notes. You ready to see these problems then? What is u? Anybody want to guess? Root of x. And the reason why u is the root of x, and so I can't always tell you what u should be, and sometimes there's multiple options for u. But generally speaking, it's the thing on the inside. But here's the real answer. U is that thing that when you take the derivative of it, what's the derivative of the root of x? 1 over 2 roots of x. You come up with something that you want to substitute for. Do you see that? See, when u is the root of x, see how I get 1 over 2 roots of x? That root of x will be accounted for right there. And so therefore, that's why this is a good choice for u. Okay, so I have 1 over 2 roots of x dx. I have a dx. I have a root of x, but I don't have negative 2 over 3. So anybody see what we should do then? Let's start basic. How do we get rid of a half? Good. So 2 du is equal to 1 over the root of x dx. I don't have 1 over the root of x. I have negative 2 over 3 over the root of x. Now multiply by negative 2/3 and you get negative 4/3 du is equal to negative 2 over 3 roots of x dx. So I just played my game with my multipliers. Let's make our substitution. I'm going to put in negative 4 over 3 integral du. What goes away? What can I cross off up here? Yep, the negative 2, the over the 3, the root of x in the denominator, and the dx. And what do I put in for the root of x? I put in u. So I have cosine of u. What's the antiderivative of cosine? sine. So negative 4 over 3 sine of root of x plus a constant. Does the next one look impossible? No? Because I don't know how to do it. Honestly, I don't know how to do it. Every year I forget to change it. Instead of tangent squared, let's just do tangent. Anybody want to guess what u should be in this problem? 4 plus tangent of x. Good. Somebody, what is the derivative of 4? Nothing. What's the derivative of tangent? Ooh, isn't that fortunate? Look at that. It's like Christmas. So I get to get rid of this, and what do I put in its place? Yep, just integral du. That's all I have to put in its place. Instead of 4 plus tangent, what do I put? I put u, and the thing that's left over is the cube, so it's u to the third. Antiderivative of u to the third plus a constant. So I have to substitute back in for u, so I have 4 plus tangent of x to the 4th power over 4 plus constant. It's not too bad, is it? But isn't it interesting that we're taking an antiderivative and you're taking a derivative? Do you see how sometimes people get confused? Good. Flip it over. Does 5 look impossible? What should u be? Actually, it's just going to be 1 minus x squared. So what is du? Yep. Here's why. Notice that if I had this, suppose I had 1 over the root of x. Can you find the antiderivative of that? Yeah, this is like x to the negative 1/2, agreed? So I don't have to get rid of the root of x in order to find an antiderivative. Furthermore, consider this. When you choose u to be this guy, your derivative leaves you with an x to the 1st power. See that? This is the thing that's bothering me. I have an x to the 1st power. So I choose u to be something so that when I take the derivative, I'm left with an x to the 1st power. The 3 is of no concern to me. The constants we can play around with and get to go away, right? This x, that's the problem for me. So how do I get a 3 there and not a negative 2? Divide by negative 2 and multiply by 3. I like that idea. Let's divide by negative 2 and multiply by 3. So I'm going to get rid of the 3x dx, and what do I put in its place? Good. What do I have left? 1 over the root of u. Agreed? Which is u to the negative 1/2. What is the antiderivative of u to the negative 1/2? U to the 1/2 over 1/2. I'll write it out. Negative 3 over 2 times u to the 1/2 over 1/2. Instead instead of dividing by half, I multiply by 2. What's going to happen? 2's cancel. And you get negative 3 square root of 1 minus x squared plus c. Try the next one on your own. So u is equal to x squared plus x minus 1. What was du? 2x plus 1 dx. And this is not that, but if I multiply through by, so 2 du is equal to 4x plus 2 dx. Isn't it nice that this was just a little bit different? You know what I mean? If this was a plus 3, the problem would be much, much, much more difficult. In fact, we might not be able to solve it. So antiderivatives can be super challenging. This one works out pretty nice. So I substitute 2 du, and in its place, I have, well, this is gone, and that's gone, and this I substitute u. So what remains? Yeah, u to the negative third. And the antiderivative of u to the negative third is u to the negative 2 divided by negative 2. Notice how the 2's will cancel. So you get negative 1 over u squared. So it should be x squared plus x minus 1 squared plus c. I think that's right. Yeah. Okay, Abby asked a really good question earlier. We're almost done. These last two are complicated. They're really not that bad. The question is, how do we choose u? Anybody want to guess? We have 2 choices for u. What do you think our first choice is? E to the x. What's our other choice? E to the x plus 1. The question is, should we choose the top or should we choose the bottom? Take 20 seconds and decide with a friend. Go. Five, four, three, two, one. I heard a lot of people say that we should choose the bottom. Why? Because when you take the derivative of this, you get that, right? But when you take the derivative of this, you don't get that. So that's a great summary. That's why I have this problem there. So we say that u is equal to e to the x plus 1. So what is du? E to the x dx. Do we have an e to the x dx? We do. Isn't that great? Isn't e awesome? I mean, it's just a cool thing. All right. So I have the integral du. What remains? U to the negative 1, I'm going to write as 1 over u. Now this is tough, right? Because let's admit what you guys are talking about. You're saying u to the negative 1, so right now you want to add 1, don't you? And you would get u to the 0 divided by 0, but you're like, I can't divide by 0. So then you're trying to think to yourself, what was the thing we took the derivative of to get 1 over x? What do you take the derivative of to get 1? Natural log. So the antiderivative of 1 over u is natural log. And we'll get to it later, but you actually, when you take an antiderivative, you can only take the natural log of positive things, so we use absolute value. So natural log, absolute value of e to the x plus 1. And our last one, what should u be in this situation? We got sine squared, we've got cosine. Anybody else? What if I write it like this? 4 times sine of x, quantity squared, cosine of x. Is that more clear to you that u should just be sine of x? Yeah. U is just sine of x. What is du? cosine of x dx. I don't have a cosine. I have a 4 cosine. Multiply by 4. So I can now write 4 times the integral du. Very good. Yep, cosine and dx go away. The 4 goes away. And sine is replaced with u. So as you said, u squared. What is the antiderivative of u squared? U to the third. And when you plug sine back in, you get that. More customarily, it would be written as 4 sine cubed of x over 3 plus c. Just helping you again once you can understand that those are the same. I would accept either form. What do you think? Substitution? You're pretty smart? I think you have plenty of practice problems because this is not the section that people do just extraordinarily well on the test. Yes. Yes.